Okay, Friday just ate a cracker. Fridays are awesome, and here we are on a Friday. I'm retired, but well, I still have stuff I do, but Fridays are still awesome. They got a good vibe to them. My son's home, daughter's around. It was her birthday yesterday. Pam's out there reading the newspaper, and we're gonna do something super fun. It's our anniversary, 31 years. So we're gonna do something super fun today. Probably end up going out to the coast just because of the heat and stuff. But anyway, we're gonna talk about stuff today. I'll try to go a little quicker. I was long yesterday, but weather off the top. If you can bear with us, it's gonna get hotter. We'll do the weekend forecast. We'll do a long range forecast. And then we'll go into more superfluous stuff like surf, puffins, bears, cloud seeding, which I think will be interesting. I know just enough about cloud seeding to be dangerous, but cloud seeding, it's in the news right now because of the sad flood that they had down in Texas. I mean, the numbers are staggering. I mean, they are staggering. Like, was it 120 people lost, something like that, as I looked yesterday. And then I saw like, gosh, it was like over 500 people missing. So that's terrifying to me. I feel like that number can't be right, but hopefully it's wrong, or hopefully that they find those people. But anyway, cloud seeding kind of came into it because some company was cloud seeding up the range and blah, blah, blah. I'm not going to get into the soundings or anything like that, but I'm going to talk a little bit about cloud seeding as a whole and what I learned in my time in climatology at Berkeley about cloud seeding. Again, this is dated. I'm sure technologies have changed it, but ironically enough, cloud seeding, back when I was in school in the 70s and 80s, they were using silver iodide and dry ice. And you know what they use now? Silver iodide and dried ice to get raindrops to form onto that as a nuclei. Okay, so we got to talk about heat warnings in the Bay Area, increased fire danger, yeah, air quality, weird. We're going to talk about cloud seeding a little bit. We're going to talk about fire. There's the green fire still raging. We'll check and see how much control, or if any control, on that. We'll look at the bears, the puffins, and stuff like that. I got a bunch of stuff lined up today. But this is starting off. This is the green fire, and I just wanted you to see. Let me back it off a little bit here. This is this morning. You can see the hot spots on the ridge line. And you can bet the men and women at CAL FIRE are working their butts off all night doing this. Matter of fact, I just realized, let's go back. I want to see how long they were working on that fire. This is all night. This is last night. Smoke, and then you can see this is early in the morning. So there's some hot spots. They're working those ridge lines, and as long as they don't come down the backside of that ridge, right? And then there's the smoke from this morning. It sets down. It's into Cottonwood, Redding, Red Bluff. A lot of smoke. It is still putting out copious amounts of smoke. The fire is aggressively putting smoke into both. There's a lot of fires. There's a bunch of smaller fires up in Trinity, actually a large fire up in the Trinity Alps area. The main smoke problem for us, though, seems to be the green, which is pushing smoke into Sacramento. I don't see any air quality concerns today in terms of air quality district, but I wouldn't be surprised if they issued something. And it's generally higher when it gets into the Bay Area. It'll make for an awesome sunset tonight up on Mount Tam. But down in this area, right in here, in the morning, that smoke just sinks, right? Cool air sinks, the morning out of the canyons drops in, and you get this smoke. And it's not actually all that cool in the north, but there's the drainage basins and the rivers. It is cooler in those canyons, and the air drifts down. So that's a live, or a pretty close to live visible satellite. This is us this morning. This is us. This is kind of my region, the Bay Area. But we're looking at all of California. When we look at the marine layer, you can see, first of all, smoke. You can see the marine layer. I show you this over and over again because I want you to go, oh, yeah, Mount Tam's 2,500 feet. We're looking down on the fog. It looks like, Mill Valley's in here. That ridge line is about 1,000 feet. Just take the coastal hills and go, it's about 1,000 feet. So it's kissing it, right? So the marine inversion, as it bends out, it's about 1,000 feet, 1,200 feet. And that tells you that fog is not getting very far inland, especially when you see this scoop like this. It's very familiar, very photogenic. But when you see it start to refract and bend down like that, that's the high really suppressing the marine layer and pushing. The fog's trying to get in, and it's climbing up over the hill, and the fingers come in. So that's a really very strong high pressure ridge that is forming. So you can see it this morning. You can see the waves. You can see Montera Mountain. Beautiful day. If you've never gone to the top of Mount Tam, you may want to consider it. It's really beautiful. Today'd be a good day too, because the fog's going to break a little bit. You can see it kind of trying to clear out now, and see the high pressure pushing the fog back. So that's just a visual. That's like when I talk about high pressure, you're like, what do you mean? Well, that's what I mean. You forget the hydrostatic equation. Just go, man, look at that. That's air is sinking because the air is sinking. Right? Or the cooler air is sinking because the air is sinking. High pressure zones, the air sinks. Air is interesting too, because generally it warms, cools as you rise. We call that the environmental lapse rate. Cools about 3 degrees per 1,000 feet. Cools as it goes up. Air rises, it cools, it expands. And when the expansion is cooling, that's how your air conditioner works, right? The gas expands and it cools. And then air that sinks, right, is compressing and it warms. More aggressively, it warms at about 5 degrees per 1,000 feet. So if you're at the top of Mount Tam, which is 2,000 feet, the temperature at the bottom, if there's no fog, as the air sinks, is going to be 10 degrees warmer. Right? So, yeah, just a little bit. We've talked about that before. This is the inversion. I'm going to put you there. This is about 2,000 feet, right, or 1,000 feet right here. So that's what we were looking at, right? So right about there. And you can see it's been like that since yesterday. Tomorrow, the marine inversion is going to come up a little bit, just a little bit, around 1,400 feet, but it's still going to be a very warm day. It might be a couple degrees, or a few degrees cooler around the bay, a couple degrees warmer inland. Here's the smoke from the green fire. You know, I used to work with a guy who was awesome, actually, Brian Sussman. We weren't really awesome friends or anything, but he did a thing when he used to. I always think about this because I'm like a broken dam when it comes to presenting. I just thoughts come in my head and then I just throw it out. I don't structure it well, but it worked for 38 years, so I do structure it well. It's more conversational, I guess. But Sussman would do this move. Mark Thompson did this too. Another guy I worked for, weather guy. Fox guy used to do, he's the voice of Fox, like American Idol and stuff. But I digress. They would pause. Like they would go, I used to try it when I was working, but see the smoke coming off the James fire? That is prolific. The winds are pause, right? And that wasn't a great pause because I don't know how to do it, but they're really good at it. Like I swear they would use half the words I would use in 3 minutes, 4 minutes. Yeah, I know. And it's a different style of communication for sure. Okay, so there's the fog along the coast. You can see clearing in Southern California. You can see some vortices developing. I saw a cool shot of a Kármán Vorticity, which is it's how can I explain it? It's like here comes the wind down the coast. It hits a little island like Catalina, and the air goes around either side of the island and spins. In the fog footprint, it leaves this really awesome design, Kármán vortices. Maybe I'll find one for you one day. There was a good one yesterday, but I don't have it on my thing here. So there's the smoke. Smoke's going to get a little better this afternoon. Let's take a look at the GFS. This is the ridge of high pressure. See it? Let's see if you can see it. So here, it's a broad ridge. So this is the jet stream, little trough out in the east, just a little one. But this jet stream, see how it's broad? If the ridge was like this, which we get sometimes in the winter months, they break down and move really quickly. Broad ridges like this don't move very quickly. So what I'm saying is this broad ridge is going to hang out, and it's going to be hot again tomorrow, hot again on Sunday. Heat advisories tend to roll into Sunday, Monday of this week for parts of California. So is it biblical heat? No, there's enough going on underneath it, enough little bit of energy to keep it from getting really hot, but it's going to be hot next couple of days. Fire danger's up, air quality down, drink plenty of fluids, pay attention to the pets and the elderly. And then here is this cool down, right? You can see that. See that? Okay, see there's the black lines that are parallel. See how they drop down from Oregon? And that's because that system way up there, that red, blue, purple thing, that's a vorticity maximum that's cutting it down. And then there's your cooling, Tuesday, Wednesday, and Thursday. Well, Tuesday night into Wednesday, Thursday. And then significantly cooler as we go into the 19th, Saturday, next weekend. Okay? So would that happen? Could. Probably will, to some extent. This is, let me see here. Let me move this here. I got to get better at that. Okay, so overnight low is pretty warm. This is the HRRR, updates every hour, about one kilometer square grid. It's about as finely meshed a model as you can get. So it's really high resolution, but in terms of how far it can go out, 24, 48 hours tops, right? Something like that. The GFS, which is big, large mesh, large grid, I think like over, I can't remember what, 4 kilometers, something like that. It goes out further, and some of the other models go out further, the 25 kilometer grid. So I'm just trying to point out that this is our finely meshed model that is saying this afternoon, this is how hot it's going to be. And you can read the numbers as I pop in here. Temperature 108 up towards Redding, 110, 109 Red Bluff, right? You can see these numbers. That top number, it toggles as I go down the valley. You go up to Lake Tahoe, you're at 80 degrees, much cooler. Makes sense, right? Temperatures warm 5 degrees per 1,000 feet as the air sinks. So Lake Tahoe's at 6,000 feet, so it's 30 degrees cooler. Kind of do the math, right? Kind of works. It's broad brush, but it works. Okay, so there we go. And this footprint goes into tomorrow as well. These are the forecast highs for today, or if you will, the daytime highs from today. And, gosh, often 120, that 120 just is frightening. A couple times I was in 120 in Chico back in the 70s, late 60s. I think it was 120 or something. And it was messed up. Like I was a little kid and it was messed up. When I grew up, we lived in the rivers. This is today. This is in the canyons, like Butte Creek and the Feather River Canyon. I basically was raised in those things because air conditioning wasn't really a thing. We certainly didn't have air conditioning at the high school or the junior high. Didn't have air conditioning at the grammar school. So especially in the, it's obviously summer now, but we'd get some hot days without it. But there wasn't a lot of air conditioning in the day. So you lived in the rivers, Lake Orville, so on and so forth. We're lucky to have it too, because of that heat. Like Chico, they'd all go out to the Sacramento River, out to Scotty's. And we tubing down from Hamilton Bridge. I can't remember which bridge we jumped in at, but tubing was fun, dangerous, especially early in the spring. These are the numbers for tomorrow, so it's going to be a little bit cooler. Okay, here is the James Fire. Let's come in a little closer here. See if I can get in there. We'll check it out. Yeah, so still no containment on the James Fire. This is the James Fire here, right? And still no containment on it. They're saying zero containment, almost 6,000 acres. And you can see some of the evacuation zones. It's a really remote area, So I don't think there's many structures in there, but it's something to consider as the fire grows. Most of the energy right now is I think, early on in this fire, we had sort of a more southwesterly flow, so the fire burned up canyon, and now the winds are more northerly, so that's why the smoke's coming in. I think the fire's burning. It's almost like a backfire. It's burning back on itself, which I think is helping. But again, containment in a zone like that, again, this is what it looks like. I mean, where you see a road, I don't see a road anywhere. I mean, there aren't many roads in there. But you just, it's tough to get to, but you also can tell that there's not a lot of structure in there as well. So this is watchduty.org. Let's see if we can pick up the fire. There it is. This is from the fire. This is just taken moments ago. And you can see the smoke lifting a little bit. It does feel, based on the pictures, that they are getting a little bit of a handle on it, because you're not seeing, like even last night's shot of, look like less hot spots, but I'm just eyeballing it. Got a little fire burning down here in San Diego, Springs Fire, 50 acres. They got 20% containment on that. This is a fire.gov, california.gov, or actually fire.california.gov page, which I don't use a lot, but Holt Hanley, who was my intern back in the day, you may know Holt, he has a fire weather page, and he's awesome. I asked him, where'd you get that camera? Because I love that you got the topography so nicely. Well, sorry, I'm not savvy with this map yet. But I love that you have the topography in here. Let me back it out a little bit so you can see where we are. So you can see Montgomery, Point McLeod. You can see Shasta Lake right here, Shasta, and here's the fire. And so you can see the areas they're most concerned about. And the fire is kind of burning in this zone. So again, there's not a lot here. You got the Pitt River on this side, you got the McLeod River on this side, and then that ridge line just up the middle. The air quality is most certainly being impacted aggressively. We saw the pictures, and now we're going to see the air quality, and it's bad, right? I mean, that's bad. And air quality, that's what I was saying about air, the heat and air quality. You put those two together, and if you're old and you're a little crotchety and maybe compromised in the lungs, I gotta believe this is just almost hell for you. So look at Chico's air quality today. I mean, that's nasty, really nasty air quality. Red is, that's bad. Let's see what it says. There's a 10-minute average. Some members of the general public may experience health effects with 24 hours of exposure. So the red is not good. And then we can look at the purple. And the purple, I think, is health alert. The risk of health effects is increased for everyone. So that the purple, I guess if I was to look at this aggressively, I would just go, okay, the purple then is clearly the worst, but the red is not good, and the yellow is bordering on that. Even look at the Bay Area, San Mateo County coastline. Interesting. I mean, that makes sense. Sure. And then LA, a lot of this particulate matter is right here. LA, they're not really necessarily seeing smoke. That's just stuff from cars, right? PM 2.5 and PM 1.0. 2.5 is the worst stuff, but some of the worst, and even lower to 1.0 because it's smaller and it gets into your lungs. This is a shot looking from, I think this is looking out towards Red Bluff. No, this is looking back towards, kind of towards Big Bend, if you will. So you can see some of the smoke. That's right now. And then this is Red Bluff, Chico area. And you can see the valley haze and the fog, or the smoke. And you can see we're right about the level of the inversion. So let's see, how do we know that? Let's see, that might be interesting if we see the elevation here. Sorry to have to do this on the fly, but 2,000 feet. Yeah, so you're just above the inversion for the most part, looking down at the smoke in the valley. And without a lot of wind today, that smoke is going to linger. So you can see the smoke now. This is just a smoke model. It's not granular at all. But you get an idea. You go, okay, there's smoke in the area. And this takes you through, this is 8 o'clock tonight, or actually that was last night. Now we're into today. And you see the smoke. See how it's spreading a little bit? That north wind carrying the smoke down the valley. And tomorrow morning is going to be about the same in terms of smoke coverage. It's going to be hot. Next couple days. Okay. And then here are the heat advisories, heat warnings. We'll just take a peek at one up towards Chico and Yuba City. So heat impacts. You can see an extreme heat warning just east of Eureka up in the hills, Trinity Alps. And then you can see the heat advisory down towards Merced and up around Nevada. And one of the things to note is you go, well, why no heat advisory here? You know why, right? A little bit of a sea breeze that gets through the gate. Whatever is available, it's something. The rest of these guys are kind of landlocked in terms of the ability to get a sea breeze in there. So hot day. And then let's see if I go back. It's interesting. Whenever I do these, you guys, I'm sort of like, sometimes I go, oh, this is awesome. Everything's tying together. And then sometimes I'll go, like in my head while I'm talking, I'll go, I don't know if that's making sense. I don't know if that, and then it's like, right? So it's sort of, and then I used to redo them. And then finally I just got to the point where I go, oh, you guys just bear with me. I mean, I don't mean to drag you through anything, but it's an honest effort to do. Because we're covering a lot, right? We're trying to cover this state of California, and now we're looking at the United States and those heat advisories, heat warnings, which last through Sunday and into Monday. The heat's kind of died down a little down here, which is awesome for them being Phoenix and southeastern California. And then this is the 6 to 10 day outlook, indicating that cooling that is going to probably occur as we go into Tuesday of this next week, right? Which makes sense. So I show you these models. This is rainfall above or below average. I just show you this to go, okay, because we just look at the models, and the models are what feed this thing. So you can go, oh yeah, look, that's what we know already. We already know that it's not going to rain a lot. I didn't talk much about the monsoonal potential, but there is some monsoonal moisture coming up as far north as Whitney and down towards, Southern California. So we'll start seeing some North American monsoons shortly. This is Pacifica. The fog is in shallow and deep. Take a minute here. I think this is a good shot to sit on, isn't it? Yeah, let's do that. Want to talk a little bit about cloud seeding, just quick, only because I was watching the news last night, and this Texas thing they were talking about the cloud seeding and how that most likely or could have caused, and you can't make that correlation is difficult to make. What I know about cloud seeding, I wrote a couple things down. First of all, they do use dry ice and silver iodide. You either launch it from a helicopter from the air, or you launch it, you shoot it up into the atmosphere. The thing to know about cloud seeding, though, and I believe this is still true. I'm not up on the most current technology, but knowing that they still use dry ice and silver iodide to seed the clouds, that gets a little particulate into the atmosphere, and it gives the water vapor something to cling to, and then it starts to grow. The cloud starts to, the water drop grows around the particulate matter, which is the silver iodide or the dry ice, and it gets big enough and it falls. Okay, so first of all, are you going to seed a cloud are you going to get rain from a cloud that's not going to rain anyway? I don't think so. If you do, it's just going to be barely anything. Are you going to, or do you just seed a cloud that is mammoth, ready to rain, and you're going to get more rain? That's probably what you do, and that's kind of always traditionally been the case. And some of I think the most interesting component of cloud seeding is, so first of all, do I think that cloud seeding has something to do with the Texas disaster? No, I do not. I don't think there's a one-to-one like that at all. I haven't done a deep dive into it, but just what I know. One of the things to know, too, about cloud seeding is China did this move, which I thought was interesting, and apparently it worked, but at least we were told it worked. But during I think it was 2008, the Beijing Olympics, opening ceremonies, they didn't want, I think it was going to rain, and so they went upstream and just seeded the bejesus out of the clouds, drained them, right? So you didn't get rain or as much rain on your opening ceremonies. Did that happen? It sounds like it did. Was it going to rain anyway? Not sure. Might have, might not have, right? So there's a little bit of that. Like sometimes we'll see clouds that look like they're going to rain and it's not going to rain. So you can probably induce some amount of precipitation from the atmosphere by doing this. You probably can. Quantifying it is probably pretty difficult. The biggest thing is, and I remember this happened in 1976 or 7 during the big drought in California. I believe PG&E was cloud seeding from the air, silver iodide, and it rained, I guess, hard to quantify, but that same season or that same period, that same storm dropped less rain in Nevada, Idaho, than than they thought they should have got. So they sued California saying, you took our rain, because that's what you're doing. You're taking the rain out of the cloud and you're putting it here instead of here. So people downstream have a legit argument, I think. No matter how you look at cloud seeding, they have a pretty legit argument. And then this is the one I didn't know. In I think it's 50 or 55, in Marysville and Yuba City, they had that huge flood. When I was growing up, I wasn't born until 1958, but people talked about the Yuba City flood. It was like 20 feet of water in Yuba City, Marysville town, Sacramento River flooded. Well, it turns out that PG&E was it PG&E at the time? Yeah, it would have been PG&E. Was cloud seeding the Feather River drainage basin, right? And so, it's interesting they were cloud seeding at that time, but I guess maybe, I don't know why they were back then. And I didn't do that deep of a dive, but the city of Yuba City and Marysville sued the state or PG&E, I can't remember who it was, and I think they won the case, basically saying you guys created more rainfall, which created this flood, which caused $200 million in damage, which was a lot back in 1955 money. So cloud seeding, I'm not on board with it. I think, anytime you're geoengineering like that, and I've talked about this too. They did a thing, one time they talked about dropping atomic bombs into hurricanes, justifying that, oh, well, this is right, obviously right during the nuclear thing. They go, well, we can blow up the hurricane. That's going to save millions of dollars and, with the nuclear bomb. They've also tried it with albedo up in the Russians at one point had a plan to put ash over the polar regions, right? So the albedo, the reflectivity, is decreased, and the absorption, because of the darker ash, would melt the snow. Melting the snow would change the position of the jet stream. Water levels change, temperatures change. Jet stream moves. California no longer the breadbasket of the world, has a drought. California economy in terms of agriculture, huge in the world, one of the 5th or 6th largest, right? One of those deals. And so the idea being we can alter climate, we can alter where the food is grown, we can alter the power structures of the world, right? It's like plankton, SpongeBob. It's like, wow. So, just a little insight. Again, I know just enough to be dangerous about this stuff. You do some deep dives, you'll find it on your own. And that's sort of my job here, is just to trigger your processes and go, oh yeah, I want to learn. This guy's smart right here doing the stretching. We used to, truthfully, back in the day, we used to laugh at dudes that stretched. I don't know why, because they're probably laughing at us, but nobody stretched back in the 70s and 80s when we were surfing. I would have gone, what is up with that dude? But that's smart. That's what I do now. This is Cardiff Reef, cloudy, foggy, cool, and a little bit of swell. Swell comes up again this weekend, Saturday. I think it comes up a little bit on, let me check. I should look. I thought it came up. Let's see. Yeah, it stays slow. Look at that. So this is all the way through. Wow. SoCal doesn't get surf until a week or so away. Huh. All right. And then here we go. If you guys are here, you're awesome, by the way. Thanks for all the comments the other day, too. I appreciate it. It's nice to know you're here. And I tell my son, I go, it's kind of fun because it's a little bit of a community because we're all the same, right? We all think that they are, what are they called again? Lemurians? The mysterious people who live under Mount Shasta. We all believe that, right? I want to believe that. Mount Shasta, everybody. And then this is down in Southern California, looking towards the south and the west. This is looking out towards, let's see, I'm sorry, I did this so long ago, looking towards San Diego. Is that right? Let's see. Oh no, you're looking north towards, you're looking north towards Temecula. Okay. And then this is the hills. Just beautiful California landscape. Looking at the jellyfish, which I didn't see any this morning. I looked earlier, so we're going to pass on those. This turned out to be long. You know what the weather's going to do, though, right? You do know that we are set up for, I've queued up a bear for you. We are set up for a good heat event the next couple of days. Let me see right here. I'm going to see if there's any bears now. Isn't that interesting? The salmon, they were moving big time last couple of days. Now they're little, that must have been a pulse of fish that go through. But there have been bears. We had some good bear stuff yesterday. And then we'll check out the puffins because they kick bottom. They look happier when it's sunny. Okay, you have a great day. Think about cloud seeding a little bit, but the main thing I think is it's hard to quantify. You don't seed something that you don't think is going to rain. So how do you quantify how much more rain you got out of it? It's not really great. You're putting chemicals into the air. That's not awesome. I think the case can be made that you are stealing somebody's precipitation that would otherwise fall. So if we take cloud seed in California, we're putting Idaho in a bit of a jam. Or